Hey guys, Joe Pye here at Advanced Innovations. Welcome back to my shop. The next piece I'm going to work on, and the next piece that you're going to see me work on, is this little guy right here. Now, although I could make this out of one continuous piece, this is called out as stainless and this is called out as brass. But there's not a whole lot of room between where the stainless ends and where this notch begins to clear the connecting rod or the eccentric rod that goes on and drives that. This is the slide mechanism that goes up through the gland, around the packing, into the steam chest, and through this little guy right here, which looks like this. Ta-da. The magic of video. There you go. These are the valves inside the steam chest. Now, I did not video these because, well, first of all, these blocks, let's pop one out. These blocks almost come completely machined, which is a good thing. The pockets in the bottom and the crown is roughed in, but make sure that the little adjustment block on the inside of the steam chest fits in as it should. Now, just because I like to keep my options open, I split mine both ways so that that'll fit, just in case the overlap that they give you, and there are two different sizes, just in case I prefer one over the other. So we'll see that when that happens. Put that back in there. There you go. Now you can see that when you turn the, watch this end, right here, right there. I'm going to bottom this rod out in the steam chest. And as you turn the rod, you can see that the timing of the valve inside the steam chest is adjustable. And once this is connected to the cam, this will shift back and forth, distributing the steam or the air pressure or whatever you're using between the ports in the cylinder. It is on this end here that you need to come up with some creative solution for this guy right here. And lo and behold, the planets lined up for me, and when I went back through the hardware kit, I discovered, and I don't know if this is by design, but Stuart included two more 7BA studs of the 3/8 version. These are the short ones. So what I plan to do is I will drill and tap the end of the stainless rod. I will drill and tap through, because it'll fit, the 7BA will fit through this 1/8 easily. So this will be tapped, that'll be tapped. I will put the stud in here, put Loctite on everything, torque it down, and I say we're going to call that a day. This is 125 Imperial. That's about 3 millimeters. The OD of a 7BA is considerably less, or I wouldn't be using it. 96. That is about 2 1/3 millimeter. So let's look at the clearance we'll have for the 125. I would say that you're going to have plenty of strength here. Very unlikely that this is going to break off. And once it's Loctited in, the chances of it rotationally unloosening are very slim. So that's how we're going to approach this. I'm going to put these guys, take these apart, put them back in the lathe, cut them off to the appropriate length, drill and tap them. And in cutting them off to the appropriate length, I do plan on a small counterbore in here in the brass part to keep this concentric and all the center lines lined up as per the design intent. So there you go. Let's break these things apart, take them over to lathe, finish these guys off, and start on this end right here. This will be done from a solid block, and I believe I'm going to do one on either end of a solid block and then cut them off and call it a day. Maybe chuck up on this and put that little chamfer on after the fact. Who knows what the future holds, right? Let's go over to the collet, finish these off first. That's the easy thing to do. This is stainless steel, so it is okay to drill the hole a couple thousandths oversized to reduce the percentage of full thread. That'll make it easier to tap and less likely to snap the tap. The fork end component is next, and that is being done out of 1/4-inch square brass. This is provided in the kit, so all we need to do is turn this into that, and we're done. Piece of cake. Once upon a time, a wiser gentleman than I, when I started out, he told me, the machinist has an easiest job in the world. The part is already in there. All you need to do is remove the excess. Cake. No reason to mess it up, right? We'll see. I will do this. I'm going to drill and tap this first as my first operation. Then I'm going to go over to the mill and use the same square collet. Hopefully I can get it to clock. If it doesn't clock rotationally in a square collet block, well, I got a trick for that too. So I'm kind of hoping it doesn't line up. Let's pop this in the square collet, tap a 7BA thread to at least 406 deep. That is about 8 millimeters, 9 millimeters, 10 millimeters. That's 406, 394, 10 millimeters. Just a little over 10 millimeter full thread. And if I have to, I can always put a relief hole in, smaller than the 1/8 slot, and finish the thread. It's not a big deal. Start off in the lathe, get it going. As a habit, I always put an index mark on a collet and on the part when the part's not round. This gives me the opportunity to return the part to the collet and maintain concentricity of any features. Okay, that is a keyed collet. That is a square collet. That is a square part. That is a square block. That is a true vise. The part is about 6 thousandths out. I'd say there's 12. 7, 5 thousandths out. Almost 6. Translated to a 1 inch, that's about 20 thou. That's about 1 1/4 degrees out of rotation. Any clue on how I'm going to fix that? That is really not a problem. If you don't want to know how I'm going to fix that, and let me give you a couple of clues. No, I'm not going to shim it. No, I'm not going to take that set screw out. And no, I'm not going to use oversized stock and square it up to the block. So rule those 3 out. If you don't want to see how it's done, pause it right now, enter your comment, and then come on back because I'm about to do it. Hit it. That is true within about 3/10, and I can tell you that the material is not exactly flat, so I think 3/10 is a whole lot better than 6 thousandths. It's a considerable improvement. Any guess on how this was done? Well, let's go to a wide shot and you'll see it. Check it out. There you go. Vise and a vise. Rotated the whole setup 90 degrees, put it up on parallel so I had a reliable pivot point, and then just elevated the one end of the part, or the one end of the vise, while I was indicating it, and just watched it come in. Vise and a vise is a good trick, puts a lot of ghosts to bed, so if you don't already have a secondary vise, get one, and you can see how useful it is in this situation. Let's get to the drilling, tapping, and splitting of this part so we can finish it up. Assuring everything is tight and leveled out. First operation I'm going to do is to split it. Then I'll drill it, then we'll cut it off. And my fingers are probably going to get in the way for the registration of the saw, so forgive me for that. When I get this cutter to full depth and I'm doing the bottom half of the slot, there's an interesting illusion that takes place. The reflection from the collet and the workpiece make it look like this saw is transparent. So initially you can see the illusion, but when I offset the saw to do the bottom half, it becomes really apparent, and it's an interesting concept. That's the center half of the slot. I'm going to do the top half and an equal move to the bottom half, and watch the reflection in the top of the saw. It looks like that saw is see-through, but that's actually just an illusion. Let's move on to the cross hole. When drilling a hole across the fork like this, it's always a good idea to use the smaller drill first. That way the feature from the top acts as a guide for the feature on the bottom, and then use a bigger drill on top. Top half is a through hole because of the shoulder on the bolt, and the bottom half is tapped. At assembly, it is quite potential to screw this thing all the way down and close this up and pinch. You do not want to do that. Close it up until it makes contact and put a nut on the other side and torque it down that way. Don't let it pinch the rod. Okay. I am going to spin this vertically, put a couple of chamfers on the outside here, and blend it with a file. If you're doing this visually, try to maintain the same gap between the end of the part to the tangent of the hole and any flat that you put on there. That way when you knock the high spots off, you have a very good chance of having a good radius. Next operation on this part will be not only be to round this off with a file, try to keep it nice and clean. I mean, I could do it with a corner rounding tool, but that's cheating. I'm going to put it back in the lathe. I'm going to part it off, probably part it off to length. Going to put the part back in and face it off. Just to establish a flat surface, I'm going to take it out real quick, take an off-camera measurement, put it back in, register the tool, and make a final pass for the final length. Using an exceptionally small boring bar, this is about 2 millimeters in diameter. I'm putting a small counter bore on the end of this so that the rod that screws into it registers perpendicular to the face and concentric to all the other features. All right, let's see how many feathers I can ruffle with this comment. There's a chamfer right there. Looks like a 45 degree by about an 030. Now there is two different ways that can look when you machine that on there. You just got to work with me here for a second, because I was looking at it and I'm thinking, well, which way I wanted to attack this. And believe it or not, what they're showing you right there is not a definitive feature. You could hand that in one of two different ways if you had this as an assignment, and you would be correct either way because of the view. Now, if you look at this, this is a square part. If this part had a chamfer on all four corners at the top, that's exactly how it would look. Linear chamfers. One down the X, one down the Y, across the back, and back up the other side. So you have four corners, and right here on the edges where you have the little transition, that is a sharp corner. Okay? Or it's done on a lathe. And now you guys are going to say, there's no way that's done on a lathe, because the front would be rounded. Well, that's what I thought before, but guess what? Not so. Here's the part. Let's flip these over. Now that looks exactly like the print. But it is in fact round. If you were to put a corner 45 on all four of these corners, in profile, it would look exactly the same. So to all you engineers out there, give a third side view or a split or a top view, whatever, to determine whether or not this is what you're looking for. And I personally, I'm not sure I like that. I believe that this is probably what they're asking for, but didn't draw the line correctly. So I'm going to go with a full chamfer and just let the corners bleed out a little bit more, because that is the way I prefer it. So it'll come down about halfway into the corner here. I'm going to make it tangent with the top. I'm not going to make it this extreme, but I am going to knock these corners off for sake of just keeping it clean. And you can tell I'm working today, huh? Hands are filthy. Anyway, that is the final feature on this part. Let's pop it over in a lathe real quick, put some of those on there, and assemble it, show you what that looks like. Okay, decision has been made, and it wasn't hard to decide. I'm going to make it look like the picture. I'm going to put a little round boss on the end of this and break the corners with a file. That should serve the purpose just fine. Let's take it over to the lathe, put in a square collet, and make that happen. After the final turning out, this is what we come up with. I think it looks a lot like the picture, and I'm just going to have to go with that because that's, well, I like the way it looks. I think that it works. Let's take a look at the assembly. And there you go. Actually, there's one more piece here. Let's do this. This will get a nut on it, and there will be packing inside this gland right here. And yes, I had to make two of them. So there it is. Valve rod, the valve end, the valve itself, the crossbar for the valve. I don't know what that thing is called, but that is what it looks like. At least that's what it looks like on my bench. Next piece we're moving on to will be these guys right here. And these guys are the beasts that fit in here and drive from the eccentric sheave and make this go in and out. These will be a challenge, as they are not exactly straight. I don't know if I'm going to break it trying to straighten it out, but that is not a camera trick. That is actually going that way. And I wouldn't mind if they both went the same way, but they don't. I mean, they do go the same way, but on the model it would be nice if one was the other way. That way it would look a little bit more symmetrical if I decide to use it that way. Anyway, that is the upcoming video. If you want to see how that's done, tune into that. If you want to see a grown man cry when it snaps off, tune into that early, because I'm kind of hoping that doesn't happen, but I will heat it and try to bend it. For now, we're just going to focus on the joy of being done with these guys here. That was a fun little part to do. The 7BA threaded stud in the end of this little rod right here worked out really well. So to the guys at Stuart, if you intended for us to find those and use those for that purpose, way to go. It worked out like a charm. And if it's in the notes somewhere, forgive me, who reads instructions, right? No, I don't. There you go. Anyway, wherever you are in the world, I hope you're well and happy and safe, all of the above. Thank you for spending your time with me today. I'm Joel Pye here at Advanced Innovations in Austin, Texas. I'm out.